This is T-Dub with Data Outfitters. I'm showing you a project that I worked on with a team when I worked for Philips Respironics. Respironics is a small company that was purchased by Philips. Philips, the big company that makes computers and light bulbs and TVs and everything on the planet. They have a sleep division, and they have a watch that was developed by, well, what was originally Minimeters, which was purchased, like I say, by Respironics, then Philips. And the watch measures activity, and it stores it, and it also measures light. This particular watch is spectrum. That's what these different colors here are. These are the different colors of light that it's actually seeing. Here it's not seeing a lot of light. And the black graph here is activity. We can actually take away some of these different things here, and you'll get down to where we got pure just activity. The black is activity. You can see that in this area there's very little activity, so the software has determined that the person was asleep during that period of time. The portion of this that I really did by myself. I did a lot of this, worked on every part of it, but we needed a graph, and none of the commercially available graphs would do what we needed to do. They simply would not handle the huge amounts of data that we have. We have up to a year of data. You can see that this is going from 8:15 down here, and if we scroll all the way over, we're, well, this is only 7 days of data here, but it's probably 1 second intervals. So anyway, it's huge. So what we ended up doing was doing creating a graph using native paint functionality. This is just drawing a line from dot to dot to dot to dot to dot, calculating all of those different dots and saying, hey, draw a line from here to there. But what we also discovered was we're painting it to a picture box. The maximum number of pixels in a picture box is 32,000, and often we would have hundreds and hundreds and hundreds of thousands of pixels to paint, particularly when you start expanding this. So what we ended up having to do was create multiple picture boxes and place them next to each other and paint them as we needed. As we scroll across, we would repaint them, and it paints so fast you actually notice no hesitation, no latency, nothing. It's really pretty amazing. And what's further amazing, most of the commercial graphs, if you were to like zoom in like this, they would simply take the area that you've zoomed into and graph it. We expand that area from here to here, but we've repainted the entire data set at whatever resolution that ends up being. So I can keep expanding this to a point where every time I do this, I end up with a larger and larger and larger data set. So this thing is just huge. If I were to scroll through this right now, it just goes forever and ever and ever and ever and ever. I mean, it's really large. If I double click on this, it'll take me right back to the beginning. But you can see that right now we're moving really slow. We're covering the same amount of points. It's just more compressed. So if I keep zooming in on this, you'll see that eventually that black part becomes the whole screen, and I can keep doing that. So actually works really neat. It just tiles all of those picture boxes together. Sometimes you may have as many as 100 of them, and times 32,000. It's a huge number of pixels. It's a huge data set to deal with, but it was the only way that we could discover to make it work. And it was a lot of work, but it very, very effective. So thank you very much.